Hi everyone. Today let's make a discussion about the different type of slabs we have. As a design engineer, we want to design a particular structure for a particular case. So what kind of slab should you go for? There are different types of slab. Why should you ignore one and then go for another one? So let's get started. First of all, what is a slab? I said a slab is an horizontal structural member which is usually not subjected to bending or shear. Yes, slabs don't shear. Yeah, slabs don't shear. It can only shear when you're talking about deck, as in bridge deck. But for a normal slab, it doesn't experience shear. So it can be described as a suspending floor, which is supported by beams and columns. Yeah, let's see. This is a slab. Now look at it. The surface at which these three engineers are standing is called a slab. You can see it in red color. That red color surface is called a slab. So it is a suspending, you can see it is a suspending element here. So that's a slab. So now, what are the types of slab we have? Let's move on. The types of slab we have basically four types of slabs. We have the solid slab, you have the waffle slab, we have the rib slab, and we have the flat slab. Then under the flat slab, it is then subdivided into two: the dropping panel flat slab and the column capital flat slab. You see, first of all, the solid slab. You see this picture is still talking about a solid slab. Why is it a solid slab? Because a solid slab is a slab with a small thickness, usually around 150 mm or slightly greater than 150 mm, and it is being supported by beams and columns. So if you look at the thickness of this red slab, I'm talking about the red slab, the red colored slab, you can see that obviously the thickness is small. So, and then it is supported by beams. You can see the beam under it. This is the beam. Call it the dropping beam. So look at the beam here. Follow my cursor. You can see the beam. You can see the beam under the slab. Under the slab. Under the edge of the beam, you have a column. Also here you have a column. Here as well you have a column, and here you have a column. So you can see it is supported by what? By beams and columns at a particular interval. So the load, the dead load from the slab will be first of all distributed to the beam, then to the column, then down to the footing here, then finally to the ground. Do you understand? So where should you consider using a solid slab? So you should consider using a solid slab when you are designing a residential building, just a small residential building or a commercial building, and then the span is not too much, so you should go for a solid slab in that kind of case. And then the advantages of a solid slab is, number one, it is easy to construct. It is easy to construct. It doesn't take much effort to construct it. And then number two, the material used for the formwork is cheap. The material is usually marine board or any kind of timber you wish to use, so it is not too expensive and it is easy to get, therefore it is cheap. So number three, the construction time is fast. And number four, it is economical. Yeah, it is economical. So that's number two. Then let's talk about the disadvantages too. The disadvantage is the dropping beams. We're talking about these beams under it, the beams, that horizontal element under the slab, that's the beam. The beams, these dropping beams, they may limit the scope of design of any interior decorator that wants to work on the building after the slab has been constructed. After it has been constructed, the interior decorator wants to put some designs and everything, like and even this the POP and the ceilings. So if the thickness of the beam is too much, it may limit the scope of the design for it to be. The design engineer, the interior decorator may get stuck with the dropping beams. So that's number one disadvantage. Another is they are only ideal for shorter span. If the span is too much, you should go for another kind of slab. You should go for another kind of slab. If you look at this span here, it is not too much, and even though there are how many columns? There are 4 columns. There's one, this is another, this is another, and this is another. You understand? A solid slab, I think a solid slab cannot go more than 5 to 6 meters without columns. You understand? It cannot span more than 5 to 6 meters. So you can see it is not ideal for longer span. So that's that for solid slab. So let's move to the other kind of slab. The second type of slab we have here is the waffle slab. You see, a waffle slab is a slab with holes beneath it. You can see the holes beneath it. So it is now giving it an appearance of a waffle, or something you can call a grid. Some people, some text, they refer to it as grid slab instead of waffle slab, or this they just say waffle slab or grid slab. So you can see it here. The hole, this hole, you can see the holes, the 4-cornered hole. The hole is being formed due to the kind of formwork that is being used. The formwork that is being used is a mold, or something you can call a port, and it is being faced downward. So that is now giving it this kind of hollow. And this, it is not a beam. Don't get confused. This you are seeing that is spanning this way, it is not a beam. It is called the rib of the waffle. The rib of the waffle. So this is spanning in 2 directions. Look at it in 2-way. In 2-way direction. You have 1-way and 2-way. So this is spanning in 2-way. Why? Look at this. Look at this rib. Look at the direction. It is going in X direction, going on the here. So also this going like that. Also this going like that, and this too going like that. So that is the first direction. Then the second direction they are spanning. Look at another rib crossing it. Another rib crossing it. It is crossing it here. So it is now giving it a 4-cornered shape. Another rib crossing it, you can see there. So it means it is spanning in 2 dimensions, in 2 ways. So why should you consider using a waffle slab in any kind of design or any kind of destruction you are involved in? You should consider a waffle slab in a case where a wide or a large space or a long span is required without column obstructions. Remember, when you have a column that is not embedded in the wall, it is what? It is an obstruction. If you don't have a column embedded in the wall, it is an obstruction. So if you look at the surface, you can see it is wide. This surface is wide. Look at it from the floor here to here. It is wide. And if it is a solid slab, you can't manage not to have another column at the center here. At least one column at the center if it is a solid slab. But because it is a waffle slab, there is no column here, and it is, of course, efficient. So that's why you should use a waffle slab. So what are the advantages of a waffle slab? Number one, it uses around 20 to 25% less reinforcement than solid slab. Solid slab, it uses a lot of reinforcement, but for waffle slab, you don't need reinforcement, if at all. It uses around 20 to 25% lesser reinforcement compared to the solid slab. So we can see it is economical in terms of what? In terms of steel reinforcement. In terms of steel reinforcement, I'm not saying the total construction is economical. I'm just saying in terms of steel reinforcement. So on the number 2 advantages, they can take higher environmental load. Environmental load as in rainfall, snow melt, wind, everything like that. So it can take it with a low deflection. And if a slab should have a low deflection, you should know that definitely it will be suitable for a roof. So the waffle slab is very efficient if you use it for a roof. So you can use it as a roof slab. And when you use it as a roof slab, then there's another advantage to it, because it will have a very high noise and vibration control. It will have a very high noise and vibration control. When there is rainfall, the contact between the surface of the slab and the downpour, when they make contact, there will be a sound producing from the contact. Then, because the thickness of the waffle slab is high, you won't hear noise inside, or the noise you'll be hearing will be very low. You understand? Because the higher the thickness of a roof, the lower the noise. Because if you have a roof, what kind of roof? If it is tall, the taller it is, the lower the noise. So, or you say the higher the noise control. The higher the noise control, it means you have low noise. So, and then number 4 advantage is the soffit appearance is very attractive. The soffit appearance is attractive. Soffit means bottom, the below of something. So I'm talking about here, all this internal internal view of the waffle slab. I'm not showing you the external, but I'm only showing you the internal view of the waffle slab. You can see it is attractive. So because it is attractive, why else do you need a ceiling? You really don't need a ceiling or a POP because it is attractive enough. So you can say in terms of ceiling, it is attractive. You won't need another money for ceiling, so it is attractive in that way. So that's another advantage. So let's move to the disadvantages. Number 1 disadvantage I could think of is it requires a special formwork. As I said it requires a special formwork. The formwork is a mode. The formwork is a mode, so it is being placed upside down, and the formwork is special. It is not cheap. It's not something you can just get in a sawmill like the marine board. So it is not cheap, although it is reusable. You can reuse it, but still it is not cheap. And number 2, it requires professionalism. It requires professionalism in its design, in its construction. It requires professionalism. So that's number 2 disadvantage. I mean, high professionalism, not just professionalism. You should be professional, of course, but it requires high professionalism. Let me put it that way. So number 3 type of slab we are moving to is the rib slab. This is a rib slab. You see, some text refer this to as waffle slab too. They call it waffle slab too, but they will now call it one-way waffle slab. Because let's go back to the waffle slab. You can see this waffle slab. Look at the rib of this waffle slab. It is in what? How many dimension? It is in 2-way. There's one going this way and there's another going in this way. So it is 2-way. But if you see the rib slab, you can see that the rib is only in what? Is just in one dimension. In 1-way. Is 1-way. In 1-way. Look at it. 1-way. There is no other rib crossing it. You understand? There is no other rib crossing it. Therefore, it is what? It is 1-way waffle slab, or you just call it rib slab. Any which one you like. So the advantages, the purpose, the disadvantages, and everything, it is so similar to that of waffle slab. It's just like I can see it is less stiffer. The stiffness is lesser than that of waffle slab, and then it is lighter than waffle slab. So I think that's the clear difference between the two. So let's move to the 4th one, which is the flat slab. So this is a flat slab. You see, a flat slab is a slab without beams beneath it. They don't have beams at all. You just have the slab, and after the slab, the column follows. No beams. Look at this rib slab. There are no beams here too. This is the rib. It is the rib, not the beam. It is the rib. But even though it is a rib, it is still performing the same function as a beam. Do you understand? So we can't say a waffle slab or a rib slab does not have a beam. Yeah, of course, this is working as a beam. Do you understand? But for this flat slab, there's no beam at all. Do you understand? There's no beam at all. So this is a flat slab. So when should you consider using a flat slab in your design? You should consider a flat slab in a case whereby you don't need partition, or you need a little partition. So when you are designing, for example, a car park, a car park, look at this picture I'm showing you. It is a car park as well. So when you're designing a car park, there will be no rooms or no toilet in the car park. So there are no partition or a pavilion. Then you should consider a flat slab. So I said there are 2 types of flat slab. Number 1, we have the dropping panel, and then number 2, we have the column capital flat slab. This first one is is a dropping panel flat slab. Panel, slab. Panel is slab. Slab is panel. So when something is dropping, it means it is coming down. So if you look at it here, at this point, you can see it is part of the slab, but it increases in depth, then it comes down. So it means that at this point over the column, it means that the slab has increased, the slab has dropped, the panel has dropped. Do you understand? So it is a dropping panel flat slab. It is not just easy to connect your column straight with your slab. There should be something. So it has to be a dropping panel, or it should be a column capital. So let's see the second one, which is the column capital. You see, you don't just connect your column directly to your slab. So here this is a column capital flat slab. Look at it here. This is your column. It is coming uniformly. Then at this point, it increases. You can see it increases. So it is your column that actually increase here, not your slab. So that's why we say this is a column capital. It is your column that has a capital. Or you say it is a column head. It is your column that has a head. But here, it is your panel that is dropping. It is not your column that is increasing. Do you understand? So this is the second type of flat slab, which is the column capital flat slab. So what are the advantages of a flat slab? Number one, the height of the building will be reduced. I said it does not have a beam. So you should know that a beam will add to the height of the beam. It will add to the height of the building. And since there are no beams, of course, the height will be reduced, and that is good. And number two, it is economical. Yeah, it is economical. Yeah, then the disadvantages, it requires much columns. You can see there are much columns here. Look at it. 1, 2, another 3, 4, 5. Let's see the dropping panel. You can see this is 1, 2, 3, 4. You see, so the columns are much. So, and I told you that a column that is not embedded in the wall is an obstruction. So that's another disadvantage. Then the number two, it is not suitable for partition. It is not just suitable for you to put a partition here. And you say you want to put a wall or you want to put a room. It is not. It will be brittle. It will be brittle. So that's just it. So thank you for watching. Thank you.